digital electronics. In digital electronics, the number system is a very important and essential part of the digital electronics. Now, first, the introduction about the digital electronics. That means the introduction about the number system. Generally, we are familiar with the decimal number. We know about that decimal number, and generally that decimal symbol is namely for starting from the 0 and up to the 9. And we know about that particular thing. But most of the people doesn't know about that. Okay, apart from the decimal number, there are 3 more number systems are there which are using at the digital circuit and system and other microprocessor and other systems also. First of all, we discuss about the binary system. Second one is the octal, and third one is the hexadecimal. That means there is a 4 number system is generally used: binary, octal, hexadecimal, and obviously the decimal number. Now this means the general description of any number system. That means decimal given by the equation. That means you can convert the one decimal number to another decimal number, another number system very easily. That means n equal to dn bn plus dn minus 1 bn minus 1 plus up to the d naught b naught, where the n is the number and dn is the digit in the position and b is the base or radix of the number. Now first is the decimal number system. The decimal number system generally used in day-to-day life is decimal number system. Decimal number system has the base of the 10, and generally we have already discussed about that decimal number system. Generally it varied from the 0 to 9. Each position represents a specific power of the base. Now this is the very important things about that. Each position represent a specific power of the base of 10. Now for one example, let me give one example to you. The decimal number suppose is 1, 2, 3, 4 is generally consists of the 4 digits. In the unit position, that means to find the position. So that means position third in the 10 position, 2 in the 100 position, and 1 in the 1000 position. And its value can be written as follows. That means 1 into 1000 plus 2 into 100 plus 3 into 10 and plus 4 into 1. That means generally power is designed by the x, and the power is always be x minus 1. That means always be power is always less than 1. That means 1 into 1000, 2 into 100, 3 into 10 and 4 into 1. That means this is the 4th position is there. That means value of the power, that is value of the x is 4 minus 1. That means 1 into 10 to the power 3, that is 4th position, that is power is 10 to the power 3. Okay, and the 3rd position, that means 2 into 10 to the power 2. That means power is always be 2. That means power digit, suppose that means the x, the value of x is always be position minus the 1. Similarly, 2nd position, then 3 into 10 to the power 1, and 1st position, that means 4 into 10 to the power 0. And we can easily calculate by the addition 1, 2, 3, 4 is the final decimal number. Now this is the binary number system. There is a different characteristic of that binary number system. Generally, the characteristic of the binary system is uses 2 digit. First one is uses 2 digit 0 and 1. That is also called the base 2 number system. Each position in binary represent the 0 power of the base 2. Example, that means 2 to the power 0. That means you can is as like a decimal number. Instead of the 10, here we are using the 2. Power is always the same. That means position minus the 1. That means instead of the 10, here we are using the position. Here we are using the base of 2. In decimal, generally we use the base of 10. Suppose the last position binary number represent the x power of the base 2. Example, 2 to the power x, where x represent the last position minus the 1. For example, suppose the binary number system is 1, 0, 0, 0, 1. Then if you want to calculate the decimal number, this one is the example binary number system 1, 0, 0, 1. This one is the binary number system, and you can easily calculate the decimal number. That means first one is the 1 into 10 2 to the power 4. That means the 1 is the position is 1 is the 5th position, and the power is always the position minus 1. That is 1 into 2 to the power 4. Similarly, 0 is the 4th position. That means 0 into 2 to the power 3, position minus 1, power is always 3. Similarly, plus 0 into 2 to the power 2, and so on. and by calculating and adding the digits 16 plus 0 plus 0 plus 1, that means this one is the 17. This one is the equivalent decimal number of the corresponding binary number. Now next one is octal number system. Now that one is using the 8 digit instead of the 2 in binary and 10 in decimal. In octal number system generally using the 8 digit which start from the 0 and ending up to the 7, that means 0 to 7. That's why this is also called the 8 number system. Here generally base is 8, in binary generally base is 2 and decimal generally base is 8, but here we are using the base is 8 and power of 8 is always be position minus 1, is like the same. Now suppose that one example is there. Suppose the octal number is 10070. This one is the octal number. We can easily calculate the equivalent decimal number. Now the 1 is the position of 1 is 5th position. Then the power of 8 is position minus 1. That means 1 into 8 to the power 4. Plus 0 is 4th position. That means 0 into 8 to the power 3. Position minus 1. And that's so on. Secondly, now we can adding that particular, after multiplying, adding the digits, that is 4096. 8 to the power 4 is 4096 plus 0 plus 0 plus 56 plus 0. And that one is the equivalent to the 4152 decimal number. That means 10070. That is the octal number. That is equivalent to the decimal number of 4152. Now next number system is hexadecimal number. In hexadecimal number generally we are using the 16 digit system, that means start from the 0 to F, that was the 16. That's why the base of the hexadecimal is 16, because using the 16 number system. The first 10 number is same as like a decimal number, which means start from the 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. It's same like a decimal number, but after that the 11 is represented, 10 is represented by the A, 11 is represented by the B, 12 represented by the C, D, and 13 represented by the D, 14 represented by the E, and 15 represented by the A. Now this means the total is the 16 number. That was called the hexadecimal number system. And the same thing is that base of that particular hexadecimal number is always the 16, and power of X which will always be position minus 1. Now here we are giving, let me give an example to you. Suppose the hexadecimal number is 10FDE. Suppose you want to calculate the equivalent decimal number. The same thing is like that is 1 is the position of the 5th. Then the power of the 16 is always position minus 1. That means power of 4. So 1 into 16 to the power 4 plus 0 into 16 to the power 3 plus F into 16 power 2, D 16 power 1 plus E into 16 to the power 0. Now similarly, now F is replaced by the 15 because 15 represent the F. Similarly, D represent the 13 and E represent the 14. So here replacing that alphabetical number to the corresponding digit. Now we are multiplying that all and adding, and thus adding and find the equivalent of the decimal number. That means equivalent to 69598. This was the equivalent decimal number of 10FDE hexadecimal number. That means this hexadecimal number 10FDE, then the equivalent decimal number is 69598. Now here we are defining that how to number system, all number system can be converted into the decimal number. We can also convert that hexadecimal number into octal, hexadecimal number to the binary, that and decimal number can also be converted into the octal and all that things we are discussing the now. So okay, now thanks. I think that the time is over. So we will discuss later about that, how to convert that decimal number in other format and also hexadecimal number into octal. Thank you very much.